All right, so going back here, is the video cut off? What we have is we're trying to basically make our values, have our values drop out. So what we can see that they're trying to show us here is I do 2 times row 1. So this piece there, if I do 2 times R1, that's 2, 0, 2, 16. And then if I do R3, which is this, and I subtract them. So if I subtract those values, 2 minus 2 is 0, 3, negative 3, minus 0 is negative 3, 3 minus 2 is 1, 8 minus 16 is negative 8. So we can replace that row 3 with that equivalent expression. And so then we have, again, got zeros in this line here. We do the same idea on this last one. We're just trying to manipulate it. If I do 3R2 plus R3, so let me get rid of this stuff up here. So if I do 3R2, so that's this, it's going to go up there. That becomes a 3, 0, 15. And then I add R3, okay? 3 and a negative 3 go to 0. 0 plus a 1 is 1. 15 and a negative 8 is 7, which is where that expression is coming from. And this is in our row echelon form. All right, so what we're going to think about here is what we've actually done, right? If these were expressions for our variables, we're basically solving the systems of equation. If this was x, this was y, and this was z, and that's an 8 for our solution, right? This would translate into x plus z equals 8. All right, and down here at the bottom, we can see that this would be y equals 5. This would be z equals 7. And that is going to give us actual solutions that we could use in our other one to go from there. So this is all going to relate to solving these systems, and getting it into a row echelon form is going to be helpful and make it clearer for what those solutions look like. All right, and so what we want you to do now is we have this expression, we have a guided practice here for you to do. So you can write down in your handout. We've looked at these 2 examples. You should see, you can go back to the video and look at the example to that one. And now what you're going to do is look at our example 5. All right, so this is, we're here, the Gauss-Jordan elimination. We're going to write reduced row echelon form, and then you're going to put this example here. So for example 5, you need to take it and, write it as an augmented matrix and do some manipulations to try to figure out how to make things drop out and get into row echelon form. Be careful with this one that you don't have an x. That's going to be a 0x, and you want to make some easy things to drop out first. So kind of look at what is going to cancel easily as you go through this. All right, go ahead and pause the video now and then work through the guided practice problem. All right. We're also going to look at what happens when we have no solution or infinitely many solutions. So if we go back to what that looks like on our Desmos graph. So if I was to have x plus y equals 7, and then x plus y equals 10, and let's say we took this one out, these are never going to cross. There's no solution to that system of equations. And so there's nothing that they haven't got. There's no 2 numbers that add to 7 and then the same expression adds to 10. The alternative is if I made this, let's see, if I made it 2x and 2y is 14, now they overlap infinitely many times. I can take really any expression. So if x is 1, y is 6, and that's going to work in both of them. If x is 2, y is 5. There's infinitely many pairs that I can put together to make that work. So what we're going to look at is what that looks like as a matrix here. So as we look through this, if we want to write an augmented matrix and then apply our row operations, there's our augmented matrix, right? And then if we go through, and I'm not going to go through it as slowly this time, and make our our pieces here, what we're going to see is I have this row of zeros here at the bottom. Remember, this stands for my x's, my y's, and my z's. And so at this bottom part, I've lost a bunch of information. The way that this is going to work is identifying those values. So, all right. So we got this row of zeros here. We want to translate that back into x, y, and z. So when we look at that, what we're going to have is those are the two rows that had data, the others all zeros. So if I just look at what this means, basically I have everything x is in terms of z I could solve, and y is in terms of z, and z is just whatever we want it to be. So this is going to have infinitely many solutions when we have that a row of zeros at the bottom. We've lost a variable, and we have enough freedom to make as many ordered pairs or triples or whatever we are as we want. So that's going to be infinitely many. When we have no solutions, so let's say we have another system of equations, we write our augmented matrix, and then we step through it. And what we see at this point is 0x and 0y and 0z equals negative 12. Well, there's no numbers that are going to make that work. So this is going to have no solutions. And if we were to translate it back into our expressions, that's what that would mean. Right? So that we have infinitely many when we get a row of zeros, we have no solution when we have 0 equals an actual value. And that goes through those pieces. All right, so we have our guided practice here. Again, you're going to pause the video and you're going to look for example 6 on your sheet, and you're going to work through that problem. All right. So again, if we look at something that has infinitely many solutions, we're going to go through and write our augmented matrix, which is down at the bottom. Again, we're just paying attention to our order here to make sure that our expressions that are at the top are consistent, that the ordering is the same. Otherwise, our matrix isn't going to make sense. And then what we're going to do is use our expressions. You can work through it on your own, but basically they're just adding multiples or subtracting. This one looks scarier than it is, but basically they're just taking, since I have a negative 5 here, and I have a 0 in front of it already, I just take a negative 1/5 to get that to be a 1. All right, so that hopefully isn't too bad. So that one there is already at a 0. I just multiply by negative 1/5 to get the 1 there. Keep working to get it into our row echelon form, and then as we get through it, all the way down, we have an expression, where I have my values here. Okay, so 1 and 1 equals 4, and this was w, x, y, z. So y plus z equals 4. And since I don't have another row here, I'm going to have infinitely many solutions as I go through this. So because of this, the y plus z equals 4, that means that everything can be expressed in terms of z, where z is just any real number. And so that's going to give me infinitely many solutions as I work through this. All right, here's the expression for the ordered, for the 4 values. You can see that they're all in terms of z, which is going to allow for infinitely many solutions. All right. And those are just working through the different examples if we made different values for z and what our values for w, x, and y would be. All right, so we've got another guided practice problem. You can see we have 4 variables and 3 equations, so you should see kind of what that drops into. But you're going to write your augmented matrix, and then you're going to put it into row echelon form and see if we get infinitely many solutions, no solutions, or just one solution. Go ahead and pause the video now and then work through that problem.